Welcome to our next lecture on architectures of AI systems. Now we are going to talk about the middle part of that pipeline, which is data processing, data transformations, where your machine learning model will fit in. We'll start with a short brief introduction to ETL, extract, transform, load, and then we'll go to ELT, extract, load, transform, to give you some pros and cons of those two approaches. So let's start with ETL. As we already mentioned, the middle part of our pipeline is composed in most cases from three different parts, contains three different parts: extraction, transformation, and loading. Extract is the act or process of retrieving data from data sources for further processing or storage. As we already mentioned, we may have different types of data which may be provided to us in different ways, like batch files or streaming files. So that's why we need to have different tech stacks depending on this specifics. Transformation is a set of rules or functions applied to acquired data to prepare it for loading into the target system. So that may be a simple script or a script which has thousands of lines or your machine learning model. A loading is transferring data to the target storage. That may be a flat file, database, or warehouse, which later on will be used by your data consumers. So we have different ways of processing. First one is batch processing, which is simultaneous processing of large amounts of data using scheduled tasks. So you may aggregate some event data generated by users, so you collect them, which is here, then you aggregate them into batches and continuously transform this data and provide the data to consumers. Continuously means that batch after batch, but it may be continuous process. So this is, by the way how, for example, Apache Spark works, or Spark solutions. They also work in batches. Okay. There is another option. We may have data coming to us in a near real-time way. This is so-called stream processing. Examples are payment processing and fraud detection. So imagine that, for example, in that case, the example is in batch processing, that each week you would like to predict the behavior of your customer for the next week. For example, to predict whether this customer will or will not purchase a given product from us, yes, next week. So we may train such a model on Monday morning, make predictions on Monday morning, and then basing on those predictions, for example, continue some marketing actions. But still we process data in batch forms. But in case we have, for example, a person who would like to withdraw the money from ATM, it's impossible to ask this person to wait until 1,000 of customers will ask for such a payment, yes, withdrawing, and then collect those requests into the batch and then process, for example, to identify the fraud. It's impossible. So we need to continuously transform this data generated by either users, by sensors, okay, and provide them to consumers. This is stream processing, completely different set of methods and tools. What are the challenges of ETL, where we process data before loading? Extract, transform, load. Look, transform is before loading. What are the challenges? First, the most important challenge is too much data. In our corporate systems, enterprise systems, the amount of data being generated is growing. Transformation scripts can count millions of lines. This can make scaling the ETL pipeline very difficult. So it may happen that our transformation capabilities, like computing power, memory, etc., is too low compared to the data inflowing to the system, so we cannot process it in real time. Okay? So too much data, it may make our system stuck. We may also have different types of data, so it's not only about the volume of data, but the type of the data. We have structured, semi-structured, unstructured data, even data entity, data external data, and ETL works best with structured entity data. So for example, if you have a system where in your architecture data producers provides you with the structured entity data, yes, in that case, you may think about the ETL pipeline. So when to use ETL? For transaction data processing, customer data, product data, and all that stuff. These are the types of the data which has a structured form. Yeah. Okay. So what to do in case we do not have the capacity to transform the data before loading, to transform the data when it arrives? We may use another philosophy, extract, load, transform. So in that architecture where we have the switched, data of different types are retrieved from different sources, then they are loaded into, that should be load transform here in this graphics, they are loaded into data stores such as the data lake, and transformation occurs after loading it into the lake. The transfer data is passed on through the use. So once again, we extract the data, load it into the data lake, and then transform this after we have it loaded. What are the ELT challenges? Once again, this is a typo here, so it should be exchange, yes. Challenges. They're expensive. We have lots of data of different types that requires scalability, require a lot of resources like storage, processing. And they are relatively new, so, and as a result may be less reliable than ETL, and it may be difficult to find specialist experts in those systems. And moreover, that may be more difficult to ensure the security. But still, it solves some problems of ETL processes. So when to use ELT? Mostly for collecting large amount of data, where there's no point in processing them before loading, where data is unstructured or mixed, semi-structured. For example, data for sentiment analysis, reviews, emails, likes, etc. So if you have semi-structured, unstructured data of the event type, yep, this is probably the point to use ELT, so load before transformation. Okay, so that completes the short lecture on different types of the processing, and now we are ready to continue with the next lecture. Thank you.